All right, guys, welcome to week 4 FRQ notes. We're doing 2014 question 5. This is a non-calculator question. We've got a table here that gives us various values of the functions f and g as well as their derivatives for certain points and intervals. Part C is asking us, well, it's telling us first of all that we have this function here h, and our job is to find h prime of 3. Okay, so this is a composite function. I have ln as my outside function, and I've got f of x as my inside function. So if I want to find h prime of x, the first thing I'm going to do is I'm going to take the derivative of the outside. When you take the derivative of an ln function, it's 1 over whatever the inside is. In this case, my inside is f of x, times the derivative of the inside. My inside is f of x. So the derivative of f of x is f prime of x. So if we were to simplify this, h prime of x is equal to f prime of x over f of x. Now we want to find h prime of 3. So now I'm going to plug 3 into my h function, which means I'm going to plug 3 into f prime and also plug 3 into f. And actually that's not an f prime on the bottom, that's just an f. And then I'm going to look at the table. So when x equals 3, f is 7 and f prime is a half. So h prime of 3 is equal to 1/2 over 7. Now we could simplify this, but hey, this is an FRQ, so stop while you're ahead. Okay, let's go ahead and move on to our next one now. All right, so to begin with, it says let f be the function defined by this. For all x greater than 0, that may or may not end up being important in this particular part of the FRQ, we'll see. Where k is a positive constant. Now this is kind of a new idea. It's a positive constant. So what that means is that k is not a variable, okay? It's a constant, so it's like a number. Now that's important because we have a constant multiple rule. Anytime you have a function, you don't need to write this, but anytime you have a function that's being multiplied by some constant, like this, let's say f of x is equal to c times g of x, where c is a constant, then the derivative of f will simply be the derivative of g, and that constant will simply stay there. That's what's known as the constant multiple rule for derivatives, okay? And so in this case, that's what the k is. That k is just a constant multiple, and so it's just going to be staying there through the whole time. Now, let's go ahead and find our first derivative, and after that we'll find our second derivative. Right? So here's my function, f of x is equal to k times the square root of x minus ln of x. Now, whenever we want to take derivatives, we don't like radicals, right? We've always been changing our radicals. And that square root of x, that's going to be x to the 1/2 power. Right? So we're just going to rewrite it. Notice I didn't put my little derivative symbol in there yet because I haven't taken the derivative. I've just rewritten my radical. Next, we are going to take our derivative. Now when you take the derivative, that k is just going to stay there because it's a constant multiple. We don't know what it is, but it's just going to stay there. We are going to multiply this half to the front, however, and we're also going to take 1 off of that power, and that'll give me negative 1/2. Next, we're going to take the derivative of ln. The derivative of ln is simply 1 over whatever's right here, which is x. And then we multiply by the derivative of the inside. The derivative of x, though, is 1. So you don't really need to put times 1 here, but you can. But when it's just an x, you can really just put 1 over x. Okay, so there's my derivative. Now, I want to find my second derivative. So here we go. Let's find the second derivative now. The second derivative will be the derivative of this one. But actually, before I begin finding that second derivative, I want to rewrite this a little bit more. Because right now, this one here is in pretty good shape, the 1/2 k x to the negative 1/2. I'm happy with that guy. But the 1 over x I'm not happy with. I want to rewrite that as x to the negative 1. Remember, anytime you have 1 over, or a number over an x to a power, we're going to move the x to the top and make the power a negative. And now I'm going to go ahead and write f double prime. So now we can do the second derivative. Once again, I'm going to multiply this number to the front. So So that's going to be negative 1/2 times 1/2 times k, and then I'm going to subtract 1 from this. Now, how do you do that? Remember, you take the top and you subtract the bottom from it. So negative 1 minus 2 is negative 3 over 2. Next one, we're going to take the derivative of this guy. We're going to multiply the front by a negative, and we're going to subtract 1 from that power. All right, I'm going to simplify this. You don't have to. This is actually a good answer. And so we have this one here, and we have this one here. And my guess is that they would probably just give 1 point for each one of these, so that'd be 1 point each. Now, for this one here, I'd say it's negative 1/4 k x to the negative 3/2 plus x to the negative 2. The double negatives here become a plus, and here I just put these halves together. So I don't know, that was just looking a little bit too ugly for my liking, but you can definitely stop while you're ahead. All right, let's go ahead and move on to the last one. All right, this was 2012, question number 4. Once again, we're not using a calculator. We have a function, looks like that. They're giving me an interval. Now they want me to find f prime of x. So anytime we want to find a derivative of a function that has square roots in it, the first thing we like to do is we like to rewrite it as a power instead. So I'm going to rewrite that as a 1/2 power. Now I'm going to go ahead and do the derivative. Now the derivative of this thing will be a chain rule. And the reason for that is because we have an outside function, which is this 1/2 power. And then we have an inside function, which is the 25 minus x squared. So the derivative of the outside would be obtained by multiplying the 1/2 to the front and taking 1 off the power, and then leaving the inside the same. The derivative of the inside would simply be negative 2x. Now it's important you put that little dot there, otherwise it looks like you're doing minus 2x, and you're not. It's times a negative 2x. They're different expressions. But there is part A. And I'm pretty sure that if they were to grade you on that one, that would be a simple 1 point thing. It's all or nothing. You either get it or you don't. So let's go ahead and take a look at part B. Now, part B is asking us to write the equation for the line tangent to the graph of f at negative 3. Now, just so you guys know, when they give you an interval like this, they're telling you that this function only exists on this interval. So you're only allowed to use x values that are between negative 5 and 5. This one is between negative 5 and 5, so we're okay, but just want to let you guys know it doesn't really matter, honestly, for this problem. But let's go ahead and take a look at it. So we're looking for the equation of the line tangent to the graph of f at x equals 3. Now, as you guys know, to write a tangent line, we need an x, we need a y, and we need an m. Now, my x is negative 3. My y, we can find that by plugging the function in here. So, I'm sorry, we can plug the number in there. So that would be the square root of 25 minus a negative 3 squared, which is 25 minus 9, which is 16, the square root of which is 4. So now I've got my x, I've got my y. The last thing I need is my slope. Now, as you guys know, the slope is found by plugging your number into your derivative. Now, we already found the derivative right here. So all I have to do is plug my x value into the derivative that I've already found. Okay. Well, we already did all this, didn't we? I mean, that came out to be 16. So I've got 1/2 times 16 to the negative 1/2 power times a negative 6. I multiplied those two and got negative 6. All right, we're getting there. Honestly, you could just leave that as your slope and use that if you wanted to. If you don't know how to simplify it from there, that might be the best way to go. But I am going to simplify it just because I want to. But really, you could just say that's your slope. It's really ugly and weird looking, but you could technically say that's your slope because you don't have to do basic math on the test. So first of all, though, I am going to simplify this. So first of all, to do that, I want you to remember that a negative exponent makes it go to the denominator. So a 16 to the negative half is 1 over 16 to the positive half. Next, I want you guys to remember that a half power is really just a square root. So now we can probably see how to get the rest of the answer. I've got a half times, that's 1 over 4, times negative 6. So if I think of that as 6 over 1, I multiply all three of the tops together, I get negative 6, and I multiply all three of the bottoms together, I get 8. And so my slope will be negative 3/4 once I reduce it. So once again, you technically could have left it here, but that was just too ugly for me, so I want to rewrite it. You guys could, though. You could totally leave it there. Just got to make sure that there's no calculus involved. There's no calculus in simplifying any of this. So if you just get to a numerical expression where there's no calculus involved to simplify it, then just leave it if you want to. But it was just too ugly for my taste, so I went ahead and found the slope. So we have y is equal to the slope times x minus x1 plus y1. And you could make that a plus if you want to, because there is double negatives. Now let's just say that you didn't do what I did and you didn't find that slope. Then you would have this really weird looking tangent line. You would literally put this whole thing right here where the n is. So you would have 1 over 2 times 16 to the negative 1/2 times negative 6, and then you would have the rest of this here. So that would technically be okay. There would be nothing wrong with that. Okay. All right. So that does it for us. Now, how would they have graded that one? Typically on these tangent line problems, they're going to give you 1 point for the slope. And that means, even if you didn't simplify it, so long as you plug the number in, you got it. And then you get 1 point for the tangent line itself. It would be nice if they give 1 point for the y value, but they don't typically. So it's typically going to be 1 point for the slope, 1 point for the tan line. And that's it. All right, so hopefully that was helpful. And now you guys are going to start your FRQ practice for the week, and we'll see you guys on Monday.